Good day, learners. Welcome to mathematics lesson. My name is Nonkululeko Mboyisa. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. In today's lesson, we will be looking at probability, or we will be continuing with probability. At the end of this lesson, you should be able to use three diagrams to solve probability of consecutive or simultaneous events which are not necessarily independent. Number two, you should be able to use Venn diagrams, tree diagrams, and contingency tables to solve real-life problems. What you should be knowing already from the previous lessons and also your pre-knowledge from grade 10. From your previous lesson, you should be knowing how to identify dependent and independent events. You should be knowing how to apply the product rule for independent events. You should be able to use the Venn diagrams to solve probability problems. Okay, so today, since this lesson, it's not the first time you are dealing with probability. Every time I do a question, I'll first give you time to do it. Then I'll do it after you. Ne? So let's first look at the revision of a tree diagram. So you know how a tree diagram looks like. So in a tree diagram, you have your branches like that. And then in your branches, you will have your outcomes at this side. This is where you write all your outcomes. And then this is where you write all your probabilities here. So let's look at an example whereby they're saying, let's look at an example whereby you've got an event whereby a coin is being tossed. So if a coin is being tossed, you know that if a coin is tossed, you'll have only two possible outcomes, right? Which is you can either get the head or you can get the tail, right? And what is the probability of getting a head when we are tossing a coin? It is going to be 0.5. Where are we getting the 0.5 from? Because it's going to be the number of possible outcomes is going to be sort of the number of event H taking place. It's going to be, or the event of taking out a head or getting a head when you are tossing a coin. It is going to be 1 all over how many possible outcomes? It's going to be 2. Where am I taking the 2 from? It's from the head and the tail. Okay, so the probability of getting a head when you are tossing a coin, a tail, it is going to be 1 tail out of how many possible outcomes? Out of 2. So you can only get 1 tail out of 2 possible outcomes. So your probability, you write it here next to your branches. Ne? Okay, let's look at that example number 1. Example number 1, I'll give you 2 minutes to do it, but before that, let's go through it. It says a bag has 6 red and 4 blue marbles. A marble is thrown at random, but it is not replaced. This term, it is very important. So you've got a bag with 6 red marbles and 4 blue marbles. So what you're going to do, you're going to randomly throw out a marble, and you're not going to take it back. So it means you take out 1 marble, then the sample space is no longer going to be 10. It is now going to be 9 because you have taken out 1 marble. So you are not going to replace it. And then a second marble is then thrown and not replaced. Remember, when it's not replaced, when it's not being replaced, then it means you need to change the sample space, or your sample space is going to be affected. Ne? So I want you to draw a tree diagram for me of this scenario. Let's go through that example number 1. So you have a bag, and inside your bag, you can either get red marbles or you can get blue marbles, right? And remember, you have the first row and also you have the second row. So you'll throw a ball firstly, and then you take out another ball again. So you've got, again, you can either get a red marble or a blue marble. Again, for the second row, you can either get a red marble or you can get a blue marble, right? Okay, so our possible outcomes, it is going to be, you can either get, this is how you read it. So you'll read it from here and then you go like that, ne? So it means you can either have a red or a red. You can get a red and a blue, and you can get a blue and a red marble, or you can get a blue and a blue marble. Let me change this color. Okay, so you can get a red and a red marble, or you can get a red marble and a blue marble, or you can get a blue marble and a red one, or you can get a blue and another blue marble. These are my possible outcomes. So I've got 4 possible outcomes. Okay, so let's write our probabilities. So what is the probability of drawing a red marble when you are doing your first draw? So you have got how many marbles? How many red marbles? It is going to be 6 out of how many? It is going to be out of how many marbles? Out of how 10 marbles, because you are going to say this 6 red marbles plus the 4 blue marbles. So it's going to be 6 all over 10, which is going to be 3 all over 5. Let me just write it as 6 over 10. It's fine. Okay, and then the probability of drawing a blue marble, it is going to be 4 out of how many possible outcomes? Out of 10 marbles. So you can only draw 4 marbles out of 10 marbles. And then when you are doing your second draw, what is the probability of drawing a red marble? So in your first draw, already you have drawn the red marble. So it means how many red marbles are you left with? So instead of 6, since you have drawn out 1, it means now you are left with 5 red marbles. Are we together? Okay, all over how many marbles? The sample space, it was 10, but now we have taken out 1. So it means you are now going to be left with 9 marbles. And then you come this side. What is the probability of drawing a blue marble in your second draw? It is still going to be 4, because you only draw out the red marble, right? So it means you're still left with how many marbles? With 4 blue marbles all over how many? The sample space is going to be 9, because you've thrown out the red marble, 1 red marble. Ne? Okay. We move to the blue marble. So what is the probability of getting a red marble when already you have drawn a blue marble in your first draw? So you are going to say, okay, how many red marbles do I have? I have 6 red marbles. So it's going to be 6 out of how many marbles? Out of 9. Why is it 9? Because you have drawn out the 1 blue marble. And why is the red marble still 6? It's because you've drawn out the 1 blue marble and not the red marble. Ne? And then you move to this one. The probability of getting of drawing out a blue marble in your second draw, if you had already drawn out the blue marble in your first draw. So it means that instead of having 4 blue marbles, now you are going to have 3 blue marbles. Out of how many? It is going to be all over 9. Ne? Because the sample space now is going to change to be 9, since you have drawn out 1 blue marble. So when you are writing your probabilities, always, this is just a reminder, when you are writing out your probabilities, when you are going this side, you multiply. Ne? So it means if I were to find the probability of getting a red and a red, I'll multiply the 6 all over 10 times the 5 all over 10. If I were to find the probability of getting a red and a blue, I will say, because I'm going this side, I'll say it's 6 all over 10 times 4 all over 9. Are we together? So whenever you are going this side, you multiply. And then when you are going down, then that's where you add. And then, so in your exam, you get your full marks here. So when you are done with writing everything like that, then you can get your full marks. Okay, let's move to the questions. The first question, it is saying, calculate the following probabilities. Letter A, calculate the probability of the first marble being thrown is red. So we go back to our tree diagram. Now the answers that are in this tree diagram. So they're saying we need to find the probability of the red marble being the first to be thrown. So the red marble being the first to be thrown in the first row, then it means in your first row you can either get the red marble or the blue marble, right? So the probability of getting the red marble, it is going to be 6 all over 10, which is going to be 3 all over 5. You can also write it as a percentage. You say it's 6 all over 10 times the 100, and you'll get your 60%. Then from there you get your full marks. Ne? Then let's move to the second one. The second one, it says calculate the probabilities of throwing both marbles being blue. So both marbles being blue. So we go back to our tree diagram. We check your tree diagram. This is your A. You check your tree diagram. Both marbles being blue. You check here, you've got both marbles being red, both marbles being red and then blue and then red marbles. And then here you've got BB, which is a blue marble and a blue marble, right? So it means we are going to take this branch and also take this branch. So it's going to be that 4 all over 10 and the 3 all over 9. Okay, so the probability of throwing both marbles being blue, it is going to be the probability of getting a blue times the probability of getting a blue, because you can get a blue, ne? So the probability of getting the first blue, it is going to be 4 all over 10 times the probability of getting the second blue, we said it is going to be 3 all over 9. So the 4 times the 3, remember when you're multiplying, you multiply like this. So it's going to be 4 times the 3, it is going to be your 12 all over. The 10 times the 9, it is going to be your 90. Then if you say 12 divided by the 90, you will get 2 all over 15. Then if you write it as a decimal, when you write it as a percentage, so it is going to be 13.33%. Then you are going to get your full marks. Even if you leave it there, you'll get your full marks like that. Ne? And then let's move to letter C. Letter C, it says calculate the following probabilities. The probability of one marble being red and the other being blue. So it doesn't matter if it's blue and red or it's red and blue, but they say one marble should be red and the other marble should be blue, right? It doesn't matter the sequence, ne? So you move, you check your tree diagram, you can see that this one, it's red and red, so this one is out, and then you have red and blue. This is what we're looking for. You've got a red marble, then a blue marble. You move to the second one, you have a blue marble, then a red marble. Yes, that's what we're looking for. And then a blue and a blue, we are not looking for this one. So it means we're only going to take the red and the blue and also the blue and the red. Remember I said to you, when you are going this side, you are going to multiply. So it means you'll say the 6 all over 10 times the 4 all over 9, then you'll get the probability of getting the red and then a blue marble. And then you say the 4 over 10 times the 6 all over 9, then you'll get the probability of getting the blue marble and the red marble. Okay, so let's do that. You say let us see the probability of getting a red and then getting a blue marble plus the probability. Okay, let me just write it nicely. Let's erase here. The probability of getting one marble being red and the other being blue, ne? I'll just go down when I'm writing it because this side I don't have space anymore. So you say it's going to be the probability of getting a red marble and a blue marble, ne? Remember, when you go down, then you add. Then you say plus the probability of getting a blue marble and a red marble. So you go back to your diagram. So in your tree diagram, you've got the probability of getting a red marble and a blue marble. So that's going to be 6 all over 10 and the 4 all over 9. So it's 6 all over 10 times the 4 all over 9. And then plus the probability of getting the blue and a red marble. Okay, so you are going to say the 4 over 10 and the 6 all over 9. It's 4 over 10 times the 6 all over 9. Let me just double check. Yeah, it's 6 over 9, it's 4 over 9, then there it's 4 over 9 as well. Okay, so when you're multiplying everything, you'll say 6 all over 10 times 4 all over 9. It is 4 over 15. Use a different color. So here it's going to be 4 all over 15 plus the other side, it's 4 all over 10 times the 6 all over 9. So you'll get also the 4 all over 15. So if I'm adding here, if I add the denominators, I'll take one denominator, and then add the numerators, which is going to be my 8. So 8 divided by the 15, I will get 8 over 15. And then if you multiply that by 100, you'll get your probability as 53%. So when you are getting your marks, they'll mark for you here, and you'll also get a mark here, and then you'll get a mark like that. Ne? Okay, so let's move to the second example. I hope you understood. If you have got any questions, please don't be afraid to post in the chat. Okay, so let's look at example number 2. It says Lindiwe either walks to school or she takes the bus. If it rains, there is 30% chance that Lindiwe will walk to school. And if it doesn't rain, there is a 90% chance that she will walk to school. According to the weather forecast, there is a 40% that it will rain tomorrow. What is the probability that Lindiwe will walk to school tomorrow? So please do this one for 3 minutes. For 3 minutes, I'll give you 3 minutes. It's 14:19, so exactly at 14:21, you should be done. You do the tree diagram and you also do the question. You answer the question of what is the probability that Lindiwe will walk to school tomorrow. Let's go through the question together. It says Lindiwe either walks to school or she takes a bus. If it rains, there is a 30% chance that Lindiwe will walk to school. And if it doesn't rain, there is a 90% chance that she will walk to school, right? Okay. Let me just do it this side. So it can either rain or no rain, right? We are talking about tomorrow. So there's a probability that it can rain. There's a chance that it can rain, and then there's a chance that it won't rain. Okay, so if it does rain, there's a chance that Lindiwe will walk, and then there's a chance that Lindiwe will take a bus to school, ne? And then if it doesn't rain, there's a chance that Lindiwe will walk to school, or there's a chance that Lindiwe will take a bus to school. Ne? And then the outcomes, it is going to be rain and walk. And then if it rains, she can walk. And then if there is no rain, she can walk. And then again, if there is no rain, she can take a bus, right? So these are my outcomes. And then let's write our probabilities now. Okay, so let's read the statement again. It says, if it rains, there is a 30% chance that Lindiwe will walk to school. And if it doesn't rain, there's a 90% chance that she will walk to school. According to the weather forecast, there is a 40% chance that it will rain. So the chance that it's going to rain tomorrow, it's going to be 40%. Remember, 40% it's now your probability, right? So you can convert this percentage to a number or to a fraction. So I can divide this by 100 and I can get 0.4, right? And even this one, I can divide it by 100 and get 0.9. And then even this one, I can divide it by 100 and get 0.3. So according to the weather forecast, there is a 40% chance that it will rain tomorrow. So if there's a 40% chance that it's going to rain, it means the other 60% chance, it means that it can, the 60% it's for no rain, and then the 40% it's for the rain. So you go to this side, there's 40% chance that it's going to rain, so it's going to be 0.4 for the rain. And then for no rain, it's going to be 0.6. Why am I saying 0.4 and 0.6? Because remember, when you combine your probabilities, they need to always give you 1, right? Or if you combine your percentages, they need to give you 100%. So 0.4 and that is 0.6. And then you come this side, it says, if it doesn't rain, there is a 90% chance that she will walk to school. So if there is no rain, then there is 90% that she's going to walk to school. Okay, we go back to our tree diagram, we check, okay, so if there is no rain, they're saying there's going to be a 90% chance that Lindiwe is going to walk to school, right? So it means the chances of walking to school is going to be 0.9. And then the other percentage that is left is going to be 0.1, because remember, when you add the 2, it needs to give you a 1. Okay, and then we move to the last information that we haven't used. It says, if it rains, there is a 30% chance that Lindiwe will walk to school. So now, if it rains, there is 30% chance that Lindiwe is going to walk to school. So if it rains, they're saying there is 30%, which is 0.3% chances that Lindiwe is going to walk. Where is the other 70%? It's here, 0.7%. Sorry, 0.7, of which is that number of taking a bus. So if it rains, 0.3% she can walk, 0.7% she can take a bus. If it doesn't rain, 0.9% she walks, and then the remaining 0.1% she takes a bus. So now the question is, what is the probability that Lindiwe is going to walk tomorrow? So you go to your tree diagram, your answers, all of your answers are in your tree diagram. So you look at the probabilities whereby, or the events whereby Lindiwe is going to walk. So you've got the first chance where Lindiwe walks. If it rains, she walks, right? And then this one, if it rains, she takes a bus. We are not looking for that one. If there is no rain, she walks. It doesn't matter if she walks when there is rain or no rain. What is important, the question is asking, what is the probability of Lindiwe walking to school tomorrow? So it doesn't matter if it's raining or not raining. So again, if there's no rain, she walks. And then here, there is no rain and she takes a bus. So that one is out. So this one is out, and also this one is out. The probabilities that we are looking for, it's this one and this one. Ne? So you'll say the probability of Lindiwe walking tomorrow, it is going to be the probability of the rain and she walks plus, remember if you go down, I said to you, you add, right? And then the probability of no rain and she walks. So the probability of having a rain and she walks, it's going to be, when you go this side, it's going to be 0.4 times, you go that side, it is going to be 0.3. Then you are done with this one. And then plus, no rain and she walks, it's going to be the 0.6. And then this side, it is going to be 0.9. So it's times 0.9. When you go this side, when you go with the branches, you are multiplying. If you go down, you add. So it means it's going to be 0.4 times 0.3 plus 0.6 times 0.9. So you add, you put everything in your calculator, you'll get 0.4 times 0.3. That is going to give you 0.12 plus on the other side 0.6 times 0.9. You will get 0.54. You add everything and you will get 0.66. This is your answer. But since we are writing everything in probability, you'll say the 0.666, you multiply it by 100, then it is going to give you 66%. So there's 66% that Lindiwe will walk to school tomorrow. Okay? I hope you understand this example. Let me move to another one. Example number 3. It says a bag A contains 3 red marbles and 2 white marbles. And then you've got bag B. So you have the first bag, which is bag A. It contains 3 red and then 2 white marbles. And then you have another bag that contains 5 red marbles and then also 4 white marbles. So they're saying a bag is chosen at random and then a marble is chosen from that bag and then replaced in the bag. So what happens is that they choose a bag at random, so it can either be bag A or bag B, and then they choose a marble from that bag and then replace it in the bag. So first row, it's taking out a bag, and then secondly, it's taking out the marble. So can you represent this in a tree diagram quickly? So the question says, or the instruction says, bag A contains 3 marbles and 2 white marbles. So you have 2 bags. You have bag A and you have bag B, right? And then in bag A, what is happening? You have 3 red marbles and you have 2 white marbles. Then in bag B, you have 5 red marbles and then you have 4 white marbles. Firstly, I'm interested in writing the outcomes. Ne? So you can either get bag A with red marbles, or you can get bag A with white marbles, or you can get bag B with red marbles. Remember, you go like this, ne? You go with your branches. So now I'm in this branch. So it's going to be bag B with white marbles. Ne? Okay, now we can write our probabilities. Okay, so what is the probability of getting bag A? It's going to be 1 out of how many bags? Out of 2 bags. What is the probability of getting bag B? It is going to be 1 bag B all over how many bags? 2 bags, which is bag A and also bag B. This is my probability. I move to the second branch. What is the probability of throwing a red marble in bag A? So in bag A, I can get 3 red marbles, right? So it means it's going to be 3 all over how many marbles in that bag out of 5 marbles, right? Okay, you move to the white marble. The probability of getting the white marbles in bag A, it is going to be 2 out of how many marbles? Out of the total of 5, because we said it's these 2 marbles plus the 3 red marbles, right? Okay, and then we move this side. What is the probability of getting the red marble in bag B? Red marbles in bag B, there are how many? There are 5. Out of how many? It's going to be this 5 plus this 4, which is going to be 9. Okay, and then again you move. What is the probability of getting the white marbles in bag B? It is going to be 4. Out of how many marbles? Out of 9 marbles. Ne? Then you get your full marks just for doing that. Just for doing that, you get your full marks. Ne? Okay, so the question, it is now saying determine the probability of getting a red marble. So they just want the probability of getting a red marble. It doesn't matter if that red marble you are going to get it in bag B or you are going to get that red marble in bag A, right? They just want the probability of getting a red marble. It doesn't matter in you getting it from which bag. Ne? So you'll say the probability of getting a red marble, it is going to be equals to, you go to your tree diagram, you get your tree diagram, you get a possible outcome of, or the event of, you can get a bag A and the red marble, right? Okay, that's the first outcome. And then you've got bag A and the white. We are not looking for the white, right? So the white is out. We are getting bag B, and in bag B we are getting a red. So it means we are also happy with this one. And then we are getting bag B, but with white marbles. So it means this one is also out because we are looking for a red marble, right? So it means the only outcomes that we are interested in, it's going to be this outcome and that outcome. So it's going to be the probability of getting bag A and the red marble plus bag B times the red marble. Okay, so the probability of getting bag A times the probability of getting the red marble plus the probability of getting the bag B times the probability of getting a red marble. So a probability of getting the bag A, it is going to be 1 all over 2, right? Okay, times the probability of getting a red marble. A red marble here you can only get 3 out of 5 in bag A. It's 3 out of 5 plus the probability of getting bag B, which is going to be 1 out of 2, times the probability of getting a red marble in which bag? In the blue bag. It is going to be 5 all over 9. So you'll have 5 all over 9. Then you'll have 1 times 3, it is going to be 3 all over 2 times 5, it is going to be 10, plus 1 times 5, it is going to be 5 all over 2 times 9, it is going to give you the 18. So if you just add everything, you'll get 26 all over 45, which is, if you write it as a percentage, it's going to be 57.78%. But all in all, you'll get your marks here, you'll get your marks there, and then you'll get a mark for your final answer. Ne? Then you get your final answer. I hope you all got the same answer. Let's move to the Venn diagrams. So Venn diagrams, again, you did Venn diagrams in grade 10. So here it is just a revision. So let's look at the examples that I've given you. only events, when they only shade in P, they are only talking about event P, specifically event P, not event Q. Event Q is excluded and the outside part is also excluded. So if it's only shaded in P, it means we are saying P only. We are talking about the event P only, right? So P only shows elements that are present in set P only. Note that the intersection is also included. Why is this intersection also included? Because this intersection has got the part of Q, of the event Q, and we are looking for P only excluding the Q. So it means also the intersection we excluded. Ne? Okay, not events, not in A shows all elements that are outside event A but within the sample space. Not A is also known as the complement of event A. You also know this from grade 10, the complementary events, whereby we say the probability of not getting A, it's going to be 1 minus the probability of getting A. Ne? So we are saying everything else except this probability of A, ne? Or that event A. We move to the second one. Let's look at intersection. Intersection, most of the time when you say intersection, you're talking about end. Intersection, it's where the event A and event B intersect. So we say this part is your intersection. Ne? We represent it by end, or when we are calculating it, you use end to, or end or is multiplication, because end it's multiplication and or it is your addition. So the intersection of A and B is an event consisting of common outcomes that are in A and also in B. So that's the intersection we're talking about. And then when we move into the union, or the union of A and B is an event consisting of all outcomes that are in A or in B. So we are excluding the ones that are outside. We are talking about only the events that are in A or events that are in B, right? That the union. Okay, let's look at example number 4. Example number 4, you are given those two Venn diagrams. You've got the probability of event A. You've got your numbers from 1 up until 6. We'll only concentrate on the event of A and the event of B. Ne? So the event of A and the event of B, you have 1 up until 6. So the probability of getting event A, we are only talking about this side. We are talking about this. I don't know if you can see. So how many numbers do you have in event A? It's going to be 1, 2, and 3. So it is going to be 3 out of how many numbers in the sample space? It was going to be 6. Then when we are talking about event B, we are now talking about this part. I don't know if you can see. So now when they say the probability of getting B, it is going to be 1, 2, 3, and the 4. Out of how many outcomes? Out of 6. And then the probability of A or B. The probability of A or B, it is going to be this plus this. So it's going to be 1, 2, 3, 4, 5 all over 6. Then the probability of A and B. The probability of A and B, now we are talking about the intersection. So it means we are talking about this part, the intersection. Sorry. Okay, and then now we are talking about the probability of A only, we are talking about the 2. We don't include the intersection because the intersection has got the B, the event of B, right? So if it's A only, it is going to be this 2 out of how many outcomes? Out of 6 outcomes. And then we move to the event B only. As long as there is only, then it means we are talking about the 3 and the 5 only. We exclude the intersection because in the intersection the intersection is including the event A, and in the statement they said it's event B only. And then so with this one, you move to example number 4. it says calculate the following A up until I. We have actually just answered all the questions. The probability of getting A, or of event A taking place, it is going to be in event A, you will have the 2, the 4 and the 6, né? So it means it's going to be how many possible outcomes of event A taking place? It's 3 out of how many? Out of 6, which is going to be 1 all over 2. This is A. And then B, the probability of event B taking place. If you go to event B, you'll notice that it is everything in B, which is going to be 3, 4, 5, and 6. Then you are going to have 4 possible outcomes. Out of how many? Out of 6. Then you can write that as 2 all over 3. You move to letter C. It says the probability of not A. So the probability of not A, if it's not A, then it means it is going to be B or the one outside, ne? The one that doesn't fall under the event A or the event B. It falls under neither of the events. So you can say probability of not A is going to be, if it's not A, it is going to be B and the outside one. So it's going to be, let me just use a different color. So if it's not A, it means everything in A is out. We cancel it out. Then it means you'll be left with 3, the 5, and the 1. So it means you'll have 3 all over 6, which is going to be 1 all over 2. Or you can also say the probability of not A, it's 1 minus the probability of A, which is 1 all over 2. So you can also say the probability of not A, you can also write it as 1 minus the probability of not A. So it's 1 minus the probability of A. I made a mistake. I'm sorry for that. Remember the complementary events. So it's the probability of A. So it's going to be the probability of A. We got that it's 1 over 2. So it's 1 over 2. Then if you put everything in a calculator, you'll get 1 all over 2, right? And then you get your full marks again. And here you got your full marks, we get your full marks, we get your full marks. And then you move to letter D. Letter D, if you see that, I made a mistake, let me just correct that. So if you see that, you must know that it means that it's P, probability of not B. Ne? So whenever you see something like that on top, you must know that it means not that particular event that they're talking about. So you'll say the probability of not B, if the probability is not B, if it's not B, if B is out, then it means you can only get a 2 and a 1. So it means it is going to be 2 out of 6, which is going to be 1 all over 3. Again, you move to the probability, the letter E, whereby they're saying now write the sample space of A or B. So you go, you check. A or B, it is going to be A, which is 2, 3, 4, 5, 6. Sorry, it's 5. So A or B, it's everything in A and everything in B. So it is going to be 5 all over 6. Ne? And then, oh, no. They are not talking about the probability here. They are not talking about the probability. They just said A or B. They didn't say the probability of A or B. Ne? So it means you're just going to write the possible outcomes of A or the B. So it's going to be 2, it's going to be 3, it is going to be 4, 5, and 6. Ne? This is A or B. They didn't say the probability of A or B. Then you move to F. F is now saying find the probability of A or the B. So the probability of A or the B, you count everything inside of A and everything inside of B. So it's going to be 5 all over 6. Then you get your full marks. And then you move to G. It says A and B. So A and B. Here again, they are not asking you to find the probability, just write A and B. So A and B, this is where we are talking about the intersection. So it means you will have the 4 and you will also have the 6. So it's going to be this in between the intersection. So it can either be 4 or the 6. Okay, and then after G, we move to H. H, it says find the probability of A and the B. So now we are finding the probability of A and the B. So you say the probability of A and the B, it is going to be equal to your intersection. You've got 2 outcomes, which is 4 and 6. So it's going to be 2 all over 6, which is 1 all over 3. And then the last one, it says not A or B. So not A and also not B. So if it's not A and it's not B, then it means it's going to be what? It's going to be that one, right? So if it's the probability of not A or B, it is going to be 1 all over 6. So you can either put it like that, or you can say the probability of not A or B is equals to 1 minus the probability of A or the probability of B. Are we together, guys? Then you get your full marks. Okay, let's move to example number 5. Now you need to know how to represent your information in a Venn diagram. Ne? So in your Venn diagram, you need to know how to represent your information. Let's go through the information. It says there are 420 learners in a school, 190 learners play soccer, 260 learners play cricket, and 60 play both soccer and the cricket. Ne? So the trick with the Venn diagrams, when you are drawing the Venn diagrams, make sure that you always start with your intersection. So look at the parts whereby they are saying, they're talking about the sport, they're talking about the soccer and the cricket. So look at the parts whereby you've got learners who are playing both the soccer and the cricket. Ne? So whenever you are writing your Venn diagrams, always make sure that you are starting with your intersection. Are we together? Okay, so this is my Venn diagram. Okay, so in your Venn diagram, you've got learners that are playing soccer. Then you've got learners that are playing cricket, right? So they're saying, how many learners do you have at a school? There are 420. 190 learners play soccer. We are not interested in that as yet. And then 260 learners play cricket. We also not interested in that as yet. And then 60 play both soccer and cricket. We are interested in the intersection. So they're saying this one, they play both the soccer and the cricket. So it means in between here, I have the 60, right? So the 60 is for the intersection of the learners who are playing both the soccer and the cricket. And then we go up, it's 190 learners play soccer. So it means when I'm checking this event, this whole event, everything in soccer should give me 190 learners, because I've got 190 learners that are playing my soccer, or that are playing soccer. So it's going to be, for you to get 190, you must say 190 minus the 60 of the intersection. So you'll say 190 minus the 60, then you'll get 130. So it means you only have 130 learners that only play soccer. Then you move to 260 learners that play cricket. So it means everything in this event when I add everything here, it needs to give me 260. So how am I going to get the other learners who are playing cricket only? I'll say 260 learners minus the 60 of the intersection, then I'll get 200, right? But if you say 200 plus 60 plus 130, you don't get the total number of 420 learners. So it means they are learners who are not playing the soccer or the cricket. Ne? So you add everything, 130 plus the 60 plus the 200, you'll get 390. So if you subtract the 420, it means you have 30 learners who are not playing either the soccer or your cricket, right? So you get your full marks just for doing this. Then you are done. Are we together? So make sure always you start with your intersection. I'm telling you, you'll never go wrong with your Venn diagram. Okay, let's look at the questions. The first question, it was saying, calculate the probability that a learner chosen at random plays soccer or cricket. So it's either soccer or cricket. So it means here I am going to say, remember we said soccer, it's everything in here, and then cricket, it's everything in here. So it's including your intersection because it's everything in soccer or the cricket. So you'll say the probability of a learner playing soccer or cricket, it is going to be 130 plus 60 plus 200. You divide by the total of number of learners, which is 420. Then you add everything, 130 plus 60 plus 200. It's 390 divided by 420. So it's 390 divided by 420, which is going to give you 13 all over 14. Then you will get your full marks. Ne? Okay, let's look at another question. This one, it says, calculate the probability that a learner chosen at random plays neither soccer nor cricket. So this one doesn't play soccer and doesn't play cricket. If a learner doesn't play soccer or cricket, since those are the only two available sports, it means that learner doesn't play any of those sports, right? So it means you'll say the probability of neither soccer or cricket, it is going to be equals to 30 all over 420. So we are taking this 30 because it doesn't fall under neither the soccer or the cricket. So it's 30 all over 420. 30 divided by 420, it is going to give you 1 all over 14. Then you get your full marks, which is going to be 2. Ne? Just for doing that. Okay, and then we move to letter D. It says, calculate the probability that a learner chosen at random plays only one of the two sports. So calculate the probability that a learner chosen at random can only play only one of the sports. So it means can only play soccer or can only play cricket. So you need to say the probability of getting only one of the two sports. Ne? So it means you can have the probability of having a learner who's playing soccer only. If it's soccer only, then it's going to be 130 plus the probability of a learner who's playing cricket only, then it's going to be 200 all over 420. And if you add those two, 130 plus 200, you divide it by 420, you'll get 11 all over 14. Then again you get your full marks, like that. Okay, now we move to D. It says calculate the probability that Elena chosen at random plays only one of the two sports. Okay, no, we're done with this one. And then calculate the probability that Elena chosen at random does not play both sports. So now you need to calculate the probability that Elena chosen at random does not play both sports. So if Elena, Elena at random, let me read the question again. It says calculate the probability that Elena chosen at random does not play both the sports, right? If the Elena chosen at random does not play both the sports, it means now we are excluding the intersection, right? So if the Elena chosen at random does not play both the sport, it means that Elena can either play the soccer or can play the cricket or can play neither of those sports. Ne? So let me write this side. Let me read this question. Calculate the probability that Elena chosen at random does not play both sports. Okay. Okay, so if Elena does not play both of this sport, it means now we are excluding the intersection, right? This Elena doesn't play both of this the sports, so it means this Elena can either play the soccer only, play the cricket only, or play not play any of the sports. So the learner cannot play both the sports at the same time. I don't know if that makes sense. So it means you are going to say it's 130 all over 420 plus. You go to the probability of getting a learner who's playing cricket only, which is 200 all over 420 plus the probability of getting a learner who does not play any of the sports, which is 30 all over 420. Then you add everything. It's going to be 130 plus 200 plus 30. It's 360 divided by 420, which is going to be, it's going to be 6 all over 7. Ne? And then when we are marking, you can just say 1 and then you get 2. Or you can mark here and here. That's just 2 marks. And then we move to the last question. It is saying, calculate the probability that Elena chosen at random plays both the sports. So now the learner chosen at random plays both the sport. The learner should play the cricket and at the same time play the soccer. Ne? So we go to our Venn diagram. The probability of getting a learner who plays both the soccer and both the cricket is, how many are they? There are 16. So it's going to be probability of getting, here it doesn't play both. So here it's play both sports. So it's going to be 60 all over 420, and that is going to give you 1 all over 7. Then you'll get your full marks. You get your full marks. Then we are done. I hope when you're comparing your answers, they are the same as mine. Okay. Let's move to example number 6. We still left 2 examples. It says the probability that a person drinks milk is 0.6 and the probability of drinking water is 0.3. The probability of drinking neither is 0.2. And then you move to the questions. They say calculate the probability of drinking both milk and the water. And then B, the probability of drinking only one of the 2 drinks. So I want you firstly to draw the Venn diagram for me. Ne? So the probability that a person drinks milk is 0.6 and the probability of drinking water is 0.3. The probability of drinking neither is 0.2, right? So I said you must do the Venn diagram first so that your work is easy. So you have the probability of a person that drinks milk, and then a probability of a person that drinks water, and then the probability of someone who doesn't drink either the milk or the water. Okay, but here they didn't indicate the probability of the intersection, the probability of the person who drinks water and milk at the same time. So let's represent that as X. Then for you to get the probability of a person who drinks milk, they said it's 0.6, right? So if it's 0.6, it means if you add everything here, you need to get 0.6, right? So for you to get this one, it is going to be 0.6 minus this one, right? So if this one is a certain number, you need to say whatever that you have minus the intersection so that you can get the whole probability of the person who's drinking the milk. Ne? Okay, and then the probability of getting a person who's drinking water is 0.3. So again, since the probability of getting a person who's drinking water is 0.3, you need to say 0.3 minus the X, right? Okay, and then the probability of drinking neither is 0.2. Then we are done with our Venn diagram. So if your Venn diagram looks like this, you must give yourself a mark, and a mark. Yeah? Okay, let's move to the questions. Questions are now saying calculate the probability of drinking both water and milk and water. So if they want you to calculate the probability of both milk and the water, it means now you need to calculate the probability of getting the intersection, right? So if it's the intersection, you are going to say, okay, for you to get this one, it means when you add everything here, you need to get 1. Remember, these are probabilities, and if you add everything, it needs to give you 1. So it means if I say 0.6 minus X, I'm taking everything under milk, and then plus everything under water, it's going to be 0.3 minus X. I'm not gonna take this X again because already I've taken it when I was dealing with the milk, right? So when you are dealing with the milk, you'll take all of this, you'll take this, take this, take this, and then take this if you want to solve for X. Ne? Don't repeat, don't do a repetition. So you'll take 0.6 minus X and plus the X, and then plus 0.3 minus X plus this 0.3. So plus the 0.2, you should get 1. Because probabilities, when you add them together, they need to give you a 1. So let's check nicely. I think I made a mistake somewhere. Yeah, I left 1x. So I said it's 0.6 minus x plus 0.3 minus x plus the x. I forgot this x. This one of the intersection. So you say plus the x. Okay, so let's add everything. So you'll say 0.6 plus 0.3 plus 0.2. That is going to give you it's 0.11. Let me see. Oh, it's 1.1. And then the minus x and the plus x is going to go out. Then you'll be left with minus x. It is equals to 1. Then minus x, it is equals to 1. You take this to the side. It's minus 1.1. Negative x, it's going to be 1 minus 1.1. and that's going to give you negative 0, 1, right? And then to get rid of the negative, you divide by a negative 1 and also divide by a negative 1. So your x, it is equals to 0, 1. So it means the probability of getting both milk and water, it is going to be 0, 1. Then you are done. All right? And then you move to the second question. You get your full marks there. You move to the second question. It is saying calculate the probability of drinking only one of the two drinks. So now we need the probability of drinking only one of the two drinks. We are not looking at the intersection, so only one of the two. So it means you can only get a person who drinks milk. Let me just say only one of the two, right? So it means you can only get a person who drinks milk plus the probability of getting a person who drinks water. So it can be this one or this one. But how do I get this one? So you'll say 0, 6. Already you know what is x. It is 0, 1. So you need to say minus 0, 1. So you'll get 0, 5. And then this side, again, is going to be the same thing. It is 0, 3 minus 0, 1. That is going to be 0, 2. So it means the probability of getting someone who drinks milk, it is going to be 0, 5, only milk, plus the probability of getting someone who drinks only water, it is going to be 0, 2. And the answer is going to be 0, 7. So the probability of getting someone who drinks only one of the two, so it can either be water only or milk only. You just add the two, then you'll get 0, 7. Then you'll get your final answer. You'll get your marks, full marks. So 0, 5 a mark, 0, 2 a mark, and a mark on 0, 7, and that's your 3 marks. And then on the other one, for adding everything and equating to that one, you get a mark. For getting the answer, you'll get another marker, and that's your 2 marks. I hope you understand. If you don't understand, please don't be afraid to post your question in the chat. Okay, and then moving to example 7. Example 7, it says the manager of a hotel in Pretoria recorded the number of guests sitting down for breakfast, lunch, and supper on a particular day. Of the 300 guests, 29 did not arrive for any of the 3 meals. So the 29, they didn't arrive for any of them of the 3 meals. So the first meal, we've got 153 that were at the breakfast. We've got 145 that were at the supper. We've got 80 that were at lunch and supper, and then we've got 52 that were at the supper but did not arrive for the other 2 meals. So it means that if they were at the supper, they didn't arrive for the breakfast and the lunch. Ne? And then you've got 70 that were at all 3 meals. So this one is the intersection of both the breakfast, the lunch, and it's the breakfast, the lunch, and the supper. And then you have 161 that were at lunch, and then 95 that were at breakfast and also the lunch. So remember, when you are doing your Venn diagram, you need to start with your intersection. Ne? So let's quickly go through, let's quickly do the Venn diagram. Ne? Let's do it together. So you've got the guest that had the breakfast, and then you have the ones that had lunch, and then you had the ones that had the supper. Ne? So they said 70 were at all 3 meals. Let me check something, sorry guys. Oh, let me write my solutions here. The space, it's a little bit tiny, so let's move to the bigger space. Okay, so you've got your Venn diagram. You've got breakfast. You've got lunch. then you have supper, ne? So you have 70 that were at all 3 meals. So we're at the breakfast, the lunch, and the supper. Let me use a different pen, so I'll just put 70 here, right? And then we are done with this information. Then we move to another information. It says another, remember I said you must always start with your intersection. So now I have another information there that says 95 were at breakfast and the lunch. So 95 were at breakfast and the lunch. So now we are looking at the breakfast and the lunch, the intersection of the breakfast and the lunch. The intersection of the breakfast and the lunch, this is where we are talking about this whole intersection. So it means if I add everything here, it needs to give me 95. So how do I get 95? You need to say 90. How do you get the remaining ones? You need to say 95 minus 70. Ne? Then you will get your 25, I think. Okay, so that's going to be your 25. And then we are done with that intersection. Then we move to another intersection. It says 80 were at lunch and supper. So lunch and supper, it's this one here, ne? So it means when I add everything here, it needs to give me 80. So 10 plus, sorry, 70 plus 10, I get 80. So this one, I'm done with it, ne? And then you have 52 that were at supper but did not arrive for the other 2 meals. So it means this one, they only had the supper. So it's supper only. So you go to your supper, you put your 52 because they didn't sit in for the lunch and the breakfast. They only sit in for the supper. So this one, it's out. We are done with it. And then you move to... Let's move to the lunch. Let's finish up the lunch. So we need to find the ones that had lunch only again. Ne? So how do you do that? You can see here they said you have 161 that were at lunch. So it means if you add everything under lunch, you must get 161, right? So you'll say 161 subtract to the 25, subtract to the 70, and subtract to the 10. And you will get you'll get 56. So it means you had 56 guests who had lunch only. Are we together? So now we need to find the ones that had supper. Everyone who had supper. So now we are looking at supper. Ne? So you go to supper. Supper, they're saying they should be 145 that way at supper. So it means if I add everything here, I need to get 145. So you say 145 minus 52 minus 10 minus 70. And what are you getting there? You get 13. So it means you only had 13 that had the breakfast and the supper only. Okay, and then we move to the breakfast only. We still have one more information that we have been used. We have 153 that were at breakfast. So 153 were at breakfast. So it's going to be 153. You subtract the 25, subtract the 10. Oh, sorry, not the 10, the 70. And then you subtract the 13 as well. So you get 45. So you only have 45 there. Ne? Then you are done. Oh, no, you are not done. If you add everything here, it needs to give you 300. So you have this 29 that didn't arrive, that is outside. Then you get your full marks. Okay, let's quickly go to the questions. I'm looking at the time. We only have 5 minutes left. Okay, so let's look at letter A. The probability that both of them, they've been to breakfast, they've been to both breakfast and the lunch, but not supper. So it's both breakfast and the lunch, but not the supper, right? So it means now we are going to look at the intersection of the breakfast and the lunch, which is going to be that 25. Ne? We are going to exclude the 70. Why are we excluding the 70? Because the 70, it's including the supper, and we don't want to include the supper. So it's going to be probability of being both at breakfast and the lunch. It's going to be the intersection of 25 out of how many? Out of 300. Then you write it nicely as a fraction. So it's going to be 1 all over 12. Ne? You move to B. B, it says probability of getting okay, calculate the probability that a guest chosen at random will have been at both breakfast and the lunch. So here they're not specific about the supper with the second one. I don't know if you can see, they just said they've been at both breakfast and the lunch. They didn't say anything about the supper. So it doesn't matter if they've been to supper or not, but they should have been at both the breakfast and the lunch. So you go to your intersection at breakfast and the lunch. Ne? Breakfast and the lunch, it means you are going to take the whole intersection of the breakfast and the lunch. So you say the probability of getting both breakfast and the lunch, it is going to be 25 plus the 70 all over 300. So it's going to be 25 plus the 70, which is 95 all over 300. Then if you write it nicely as a fraction, you'll get 19 all over 60. Then you get your full marks. So the difference between the first one and the second one is that in the first one there's an exception. They said they should have been at both the breakfast and the lunch, but not the supper. So that's why we excluded the 70. But in the second one, they just said at both the breakfast and the lunch, and they didn't say anything about the supper. So it means we can just take the whole intersection of both the breakfast and the lunch. And then we move to letter C. It says calculate the probability that a guest chosen at random will have been at breakfast only. Breakfast only, it means it shouldn't have the lunch or the supper. So breakfast only, it's going to be that 45 because it doesn't include this one, or this one. So it's going to be breakfast only. It's this one. It is going to be the 45 all over 300. So it's going to be 45 divided by 300, which is going to be 3 all over 20, and you get your 2 marks. And then the last one, it says been at one or more of the meals. So now we are going to look at the probability that a guest chosen at random will have been at one or more of the meals. Been at one or more of the meals. So they are not at the breakfast, they are not at the lunch, or they are not at the supper on that day, on that particular day, but they have been in one or more of the meals. So how do you represent that one? You'll say the probability of being at one or more of the meals, it's going to be, let me just write it down. You are going to say it's 1 minus the probability of not the breakfast or the lunch or the supper, which is going to be, I think it's 29 all over the 300. On that particular day, they were not they were not counted in the breakfast, the lunch, or the supper, but they have been at one or more of the meals. So you say it's the probability of not being in any of the meals, which is going to be the probability 1 minus the probability of being of not being in any of the meals, which is 29 all over the 300. So when you put that in a calculator, it is going to give you 29 all over 300, which is 271 all over the 300. Then you get your full marks. Yeah? Let's quickly move to the two-way constituency tables. Constituency tables are a way of classifying sample observations according to two or more identifiable characteristics. For example, gender and the gym use. A constituency table shows a count or number of observations grouped by specific characteristics. Ne? Okay, so let's look at that constituency tables. A Durban gym recorded the number of members, men and women, who use or don't use the gym on a regular basis. The results are recorded in the following constituency tables. So you've got the total number of men. So you've got the men that uses the gym regularly, and the number of men that don't use the gym regularly. The total is going to be 180. You've got the women that use the gym regularly, which are 150. You've got the women that you don't use the gym regularly, which is 40. And then you've got the women that don't use, you've got the total of women, which is 190. You move to the totals. The total of 220 is the total of both the men and the women who use the gym regular. That's the total. And then you've got the total of both men and women that don't use the gym regularly, which are 150. And then when you add everything, or the number of people there, it is going to be 370. So if you add both the men and the women, it's going to be the 370. So I am going to do this example, and then you'll do the next one. Make sure that you focus. Ne? Okay, so calculate the probability that a member selected at random from the sample of 370 members uses the gym regular. So this one, okay, so they're saying now calculate the probability that a member selected at random from the sample of 370 members uses the gym regular. So if you are looking at this, it doesn't matter if it's a female or it's a male, but they just saying a member selected at random and uses the gym regularly. So it means gym regularly, it's going to be, you've got the men that use the gym regularly, which are 70. You've got the women that uses the gym regularly, which are 150, and the total of those is what? Is 220. So we just need a member. It doesn't matter if it's a man or a woman. We just need a member that uses the gym regular. So you go to the column or the row of regular, which is this one, then you'll get the total of 220. Out of how many people? Out of 370. So you'll say it's 220 all over 370. Then 220 divided by 370, you will get 22 all over 37. Then you get your full marks. You move to the second one. It says uses the gym regularly given that the member is a woman. So now it means when you are looking at your sample space, you are going to look at the sample space of what? Of women. Ne? So your sample space is now reduced to women. So now we are going to look at the member that uses the gym regularly, but that member should be a woman. Ne? So it means you'll say, letter B, the probability of getting a gym member that goes to gym regularly and that woman, that member is a woman, is going to be how many women goes to the gym regularly? It's 150, right? So it's going to be 150 all over how many women that goes to the gym in general. Oh, sorry, that uses the gym regularly. So since we are talking about the women, we have reduced our sample space to the women, so it's going to be 190. So it's going to be 150 divided by 190. That's going to be 15 all over 19. You move to letter C. It says doesn't use the gym regularly, given that the member is a man. So a member is a man but doesn't use the gym regular. Sorry. So if doesn't use the gym regularly, it means you are going to go to the men that don't use the gym regularly. Then in that case, it's going to be 110. Ne? So doesn't gym regularly, and that member is a man, it's going to be, we said 110 all over, what is the sample space of the men? It is going to be 180. It's going to be 11 all over the 18. Then you get your full marks. Okay. Okay, please quickly do this one. A group of 540 people with green or blue eyes were randomly selected in order to determine whether or not green or blue eyes are dependent on gender. The results are tabulated below. So you've got green eyes, male and female, and then you've got blue eyes, male and female, and then you've got the totals. So the first question, it says, if a person is selected at random, determine the probability that, excuse me, she is female with green eyes. So a person is selected at random, just a person selected at random. They say determine the probability that she is a female with green eyes. So you go to the people. The total people is 540, and then the people with green eyes, the total is 330, and then the total of people with blue eyes is 210. But if the person needs to be a female, then it's going to be 147 of people with green eyes that are females, and then 93 people with blue eyes that are female, and then 183 people that are male and they have green eyes, and then 117 that have blue eyes and they are male. And then these are the totals of the males and the totals of the females, right? So now they're saying find the probability that the person is female with green eyes. So I've got a female here with green eyes, so it means it's going to be that 107. It's a female with green eyes, right? Female and green eyes. So it's going to be 147 all over. How many people are there? It's going to be the 540. So you'll say 147 divided by 540. It's going to give you 49 all over 180. Then you write that as a probability, because we are finding the probability. So if you multiply this by 100, you'll get 27.22%, and that's your probability. Remember, your probability, you can also write it as a percentage, or it's written as a percentage. So B, if a person is selected at random and they have green eyes, determine the probability that she is female. So female with green eyes. So if you'll notice something here, you are now selecting people, you are now selecting a person from where? From females, but you are looking for a person with green eyes. So it means your sample space, it is now going to be reduced to females. We are not talking about everyone else, but now we're specifically talking about females. So the probability of getting a female with green eyes, already we know that is going to be 147, right? But out of how many females? Out of how many females? You go to your, out of how many people with green eyes, sorry, it's going to be how many people with green eyes? It's going to be 330. So you can only get 147 females that have got green eyes. Out of how many people with green eyes? Out of 330 people. I hope that makes sense. So you say 147 divided by 330 and you'll get the 49 all over 110. Then if you multiply that by 100, you will get 44,55%. Then again, you get your full marks and you get your full marks. Right? I hope you understand. The sample space, we need to reduce it to people with green eyes. Okay, so see, after analysis the results, after analyzing the results, a grade 11 learner concludes that the probability of having green eyes is independent of gender. Remember the independent events, ne? Is independent of gender. Is it correct? Substitute your answer with relevant calculations. Give all answers correct to 2 decimal places. So remember we said if for events to be independent, you need to say the probability of getting a female intersection or with green eyes needs to be equals to the probability of females times the probability of the green eyes, right? So if this side is also equal to the side, then you can say those events, they are independent. Ne? So let's move to going to, we have the table here. So what is the probability of getting a person with green, of getting a person with green eyes? So the probability of getting a person with green eyes, you go to green eyes, the total of the green eyes. Remember, it doesn't matter if it's male or female, as long as that person has got green eyes. Then you say it is going to be 330, you divide it by the 540, which is the total, right? And then the probability of getting just a female, it is going to be 240, because females, when you add all females, it's like that. So it's going to be 240, you divide it by the total number, which is 540. Okay, so 240 divided by, if you multiply everything there, let me see, 240 divided by 540, you get 4/9 times this side, 330 divided by 540, you will get 11 all over 18. So if you multiply everything here, you will get 0.27, right? But you are not done. You need to also prove this side. So just by looking at the first question or the first example there, what is the probability of getting a female with green eyes? We had said it was going to be, the probability of getting a female with green eyes, we had said it was going to be 147 all over 540, right? Okay, so this side, the probability is going to be 147 divided by 540. This is the probability of getting a female with green eyes. Female with green eyes, it's going to be 147 out of how many people? Out of 540. So it's 147 all over 540. So 147 divided by 540, it's equals to, you are getting 0.27. So this probability is the same as this one. So it means the learner is correct. Ne? So you say, therefore, the gender is independent of, they said, concludes that the probability of having green eyes is independent of gender. So the gender, the green eyes, now I'm not answering this question. Let's erase here. Okay, so we are saying the green eyes are independent of gender. We have used calculations to make our conclusions. So you can give yourself a mark here, a mark there, and a mark there, and then also a mark here and a mark here. I'm sorry I took most of your time. Thank you for joining in. This was your last example. So when you get home, please make sure that you look at worksheet, those worksheets that I posted for you. You have November 2018. You also have November 2018, that's question 9, and then the continuation of question 9 to 9.2. And then you have November 2017, that question 9, whereby you need to draw a Venn diagram, right? Okay, and then you have another question 9, November 2016, and then you have November 2016, 9.2. Now you need to analyze a Venn diagram, ne? And then you have 9.2.2 from November 2016 again, and then you have 9.3, and yeah, that's all for today's lesson. Thank you for tuning in, and please don't forget, you need to practice. Make sure that you practice until you get it right. Thank you for tuning in to today's lesson. Have a nice evening.